Hello everyone, welcome back to my maths homework. Let's start with the first question. So suppose a, b are two positive real numbers. If a, a1, a2 and b are in gp, and a, g1, g2, b are in, these are in ap, and a, g1, g2, b are in gp, and a, h1, h2, b are in hp, then show that g1, g2 upon h1, h2 equals to a1 plus e2 upon, that thing, a1 plus a2 upon h1 plus h2 equals to 2a plus b into a plus 2b upon 9ab. It should not be too difficult. Okay, first of all, because these are in gp, a, g1, g2 and b are in ap, so we can say that g1, g2, that's just going to be a times b, obvious. And then a1 plus a2, that is going to be a plus b, no problem. And then you have h1 plus h2. Okay, fine. So we will have to find h1 and h2 first, only then can we actually deal with this thing. Okay, so a, h1 and h2 are in a harmonic progression, h1, h2 and b. These are in harmonic progression, which means that 1 by a, 1 by h1, 1 by h2 and 1 by b. These are in arithmetic progression, which means that 1 by, okay, so these are in arithmetic progression, which means that b minus 1 by b upon 1 by b minus 1 upon a. This should be, well, 1, 2 and 3 times the difference. Okay, so the difference is going to be 1 by b minus 1 by a upon 3. Okay, that should not be too difficult. So 1 by b minus 1 by a upon 3. Okay, that's nice. So 1 by h1, that's going to be 1 by a plus this difference thing. Okay, so that will turn out to be something like, well, this is like 3 1 by a upon 3. So you take 1 by a from that, so you get 2 into 1 by a, and then you get plus 1 by b upon 3. Similarly, 1 by h2, this is h1, this is h2, is going to be 1 by a plus 2 into 1 by b, all that upon 3. Okay, no problem. Okay, cool. So let's just erase all this stuff. So let's simplify that. So if we simplify this thing, we will get 1 by h1 is equals to, so this is 2b plus a upon 3ab, and then 1 by h2 is equals to b plus 2a upon 3ab. Okay, that's nice. Let's just erase this stuff. Okay, so taking reciprocal, we get h1 is equals to 3ab upon 2b plus a, and h2 is equals to, well, what is this thing? Yeah, 3ab upon b plus 2a. Fine. So yeah, we have to prove that this thing is equal to that thing and this thing is also equal to that thing. Okay, so now we have got these values. Just erase everything else. Okay, so g1 g2 time upon h1 h2, what will that turn out to be? Well, h1 h2, that is going to be, h1 h2 is going to be equal to 9ab whole square upon 2b plus a into 2a plus b. When you okay, so we have to find g1 g2 upon this thing, so you take ab upon all this stuff. So this thing g1 g2 upon h1 h2, this will turn out to be something like ab upon 9ab squared. That has to be, okay, that's going to be in the denominator, so that will be upon, yeah, 9ab. Okay, and then this goes on the top, so we get this thing, no problem. So that's completely correct. Okay, cool. And what about this thing, h1 plus h2? Yeah, we can cross multiply that thing, so that will become something like 3ab common, and then you have b plus 2a plus 2a plus plus to b plus a, well, that will give me 3 times of a plus b. So you will get something like 3ab into 3 times of a plus b upon the multiplication of these two terms. Okay, and then you take a1 a2 upon that thing. So a1 plus a2 is a plus b. So dividing it by that, this will get cancelled, and then you get 9ab in the denominator. Okay, that's nice. And then this multiplication that comes up, right, 2b plus a into b plus 2a, that comes up, so it becomes this thing, no problem. So that was nice and pretty easy as well. Just delete this thing. Okay, cool. Let's go to the next question. The next question is, if the roots of the equation ax cubed plus bx squared minus x plus 1 equals to 0 are real, distinct, and are in harmonic progression, then, okay, so there are going to be 3 roots of this equation. All of them are real, they are distinct, and they are in harmonic progression as well. Okay, cool. Then okay, we have to find a and b somehow. Okay, well, first of all, the important information is that the product of the roots, that's going to be -1. So alpha beta gamma, that is -1, and then this thing, which is going to be alpha beta plus beta gamma plus gamma alpha, that thing is going to be -1 as well. So we can just divide it, right? Yeah, we can just divide this thing. So that will give me, right, I'm going to divide this equation by that equation. So that will give me 1 by alpha plus 1 by beta plus 1 by gamma as 1. Okay, that's nice. But now we can use the fact that because alpha, beta and gamma are in harmonic progression, their reciprocals are going to be in arithmetic progression, which means that 3 times 1 by beta is going to be 1. So beta is 1 by 3. In other words, one of them is 3. So one of the roots is going to be 3. No problem. What else do we know? So alpha, beta, gamma. Well, once you know one of the roots, we can in fact find the other roots as well using this equation. Alright, so if I take the reciprocal of it, it will give me 1 by alpha into 1 by beta into 1 by gamma equals to -1. So 1 by alpha would be beta minus some difference. So 3 minus that difference into 3 plus that difference, that has to be -1. Which means that this is going to be 9 minus d squared. So 27 minus 3d squared has to be equal to -1. That gives me that 3d squared is equals to 26. Oh no, 28. Fine. Not sure where we are going with this. Okay, that's fine. Yeah, so that is it. That should be it. Fine. So d is going to be plus or minus the square root of 28 by 3. That is completely not rational, so we can't do enough with it. But fine, we know we can actually find the other roots as well, no problem. But I think this much should be sufficient, because we can just plug this in this equation and it should be satisfied. So that means that 27a plus 9b minus 3 plus 1 should be equal to 0. Minus 3 plus 1 is just -2, so this becomes +2, which matches with this option. So that should be the correct thing. We do not know if these are correct or not, a and b, but whatever, just leave it like that. We can in fact find it out. It should not be too difficult, right? I mean, there are going to be some specific things, they are not going to have some kind of range, right? Okay, so the next question is, if a, b, c are in HP, okay, then the expression E equals to 1 by b plus 1 by c minus 1 by a into 1 by c. Wow, what is this expression? Fine, this expression must equal and we are given some options. So A, B, C are in HP. Okay, so 1 by A, I'm going to call that capital A. 1 by B, that's going to be capital B, and 1 by C, that's going to be capital C. Okay, fine. So over here what we are given is B plus C minus A. And I think we have done this kind of, yeah, we have done this kind of a question before. And then you have C plus A minus B equals to what? So now we have to convert in either B and C, or what is this thing, whatever this can be. Here it's completely in C and A, so they have eliminated B from it, and over here it's completely in B and A. The easiest would be if I eliminate B, because I can directly write B as A plus C upon 2, because A, B, C are in a arithmetic progression. Okay, because they're like reciprocals are in harmonic progression and stuff. Fine. So A plus C upon 2 plus C minus A plus C plus A minus of A plus C upon 2. Okay, so this bracket is pretty much simplified to A plus C upon 2, right? And then this bracket, well, that is going to be 2C, so you have 3C, and then minus A upon 2. That is going to be 1 by 4. Okay, so that is going to be 1 by 4 into, let's see, A plus C into that stuff. Well, that's going to be 3AC minus A squared plus 3C squared minus AC. Yeah, I think that should be it. So this becomes 2AC. Fine. So that's going to be 1 by 4 and then 2 upon AC. Yeah, so that is over there, right? This is happening, and then minus 1 by A squared. Oh, that is also over there, and then oh, that is nice. We got it on the first try itself, and also it was the easiest one. Let me just delete this. So obviously this option is correct. So this option is correct. I don't know, maybe this can be multiple choice, but whatever. If we got one of them, we can obviously try the other ones as well. Okay, so next question is, let A and B be two positive real numbers. Suppose A1, A2 are two arithmetic means, G1, G2 are two geometric means, and H1, H2 are two harmonic means between A and B. Then uh, okay, that that's nice. I can obviously tell you the answer in one shot. Okay, A1, A2 are two arithmetic means, G1, G2 are two geometric means, and H1, H2 are two harmonic means between A and B. Let's look at the previous question though. You can see that in this question we just proved that G1, G2 upon H1, H2 should be equal to A1 plus A2 upon H1 plus H2. So this is obviously correct. And then we also proved this equation, right? This equation, if you take the reciprocal of this equation, you get this thing. And then what about D? So G1, G2 upon H1, H2 equals to, that's not correct. And I got this equation, G1, G2 upon H1, H2 minus 5 by 9 equals to, whoa, what is this thing? So this is like 2 times of that stuff. Okay, let's see what this is. So G1, G2 upon H1, H2 is equals to 1 by 9 of 5 plus 2 times of this thing. Well, that's going to be 2 times of A squared plus B squared upon AB. I don't have a nice feeling about it. Okay, that is going to be 1 by 9 of, you got 5AB over there, so 2A squared plus 5AB plus 2B squared upon AB. Does this okay, let's like just erase that thing upon 9AB. Does this thing expand to that? Sure, you got 2A squared over there, and then You also got the 2b squared. You also got the 2b squared over there. What about this 5ab? So okay, fine. So you got 2a times b, so that will be that. Okay, it's not exactly 5ab. No, wait, is it? Yeah, it is 5ab. So 2a times 2b, that will be 4ab, and then b times a, that will be ab. So yes, this is also correct. 3 correct, 1 wrong. Maybe this was in fact multiple choice. Right, so these were also multiple choice questions. Uh, Fine. Well, obviously these are not exactly what the answer should be. These should be like some kind of real values, right? I mean, there can be two values of a and two values of b, but that's not working. We did not have to find an interval though, so c should be correct for that question. For this question though, it could be different, but I'm not going to go into that because that will take time, which we do not have over here. Okay, let's go to the next question. So if a b c are in harmonic progression, then a upon b plus c minus a, oh god, b upon c plus a minus b are in harmonic progression. uh let's see if the first one is correct. So let's do the first option. So what can you do? If these are in harmonic progression, then that means that b, that their reciprocals should be in arithmetic progression. Fine, so b plus c minus a upon a, and then all the other stuff, that should be in arithmetic progression. We can add 1 to each term, and that should still be in arithmetic progression, which means that b plus c plus a upon a, and then all that stuff, that should be in arithmetic progression, which means that 1 by a, 1 by b, and 1 by c should be in arithmetic progression. If we divide this by a plus b plus c, that should still be in arithmetic progression. So dividing by a plus b plus c, we get that these three should be in AP, but these are obviously in AP because ABC are in a harmonic progression. So A is completely correct. Okay, so A is completely correct. Yeah, except if A plus B plus C equals to 0. Well, I don't think that's going to happen though. So A is correct. Let's go to the next option, which is 2 by b equals to 1 upon b minus a plus 1 upon b minus c. Okay, it is more like proving that 1 upon b minus a, 1 upon b, and 1 upon b minus c are in a arithmetic progression. Okay, what can you do with that though? Well, these should be in arithmetic progression, more like b minus a, b, and b minus c should be in, I don't know, we will have to do this with a lot of hard work this time. So 2 by b should be equal to, let's see, b minus c plus b minus a upon b squared minus a plus c into, uh, is this really the best way of doing it though? I don't know. Okay, what about we multiply this equation by b? That will get rid of a lot of stuff. Okay, fine, that might help. Let's just see what we get by doing this thing. Minus a plus c into b plus ac. Okay, so let's cross multiply. So that will give me 2b squared minus 2 times of a plus c into b plus 2ac is equals to, well, you got b squared, that gives me 2b squared, so one of them cancels, fine. And then you got minus of a plus c into b, so one of them cancels, once again, so got rid of that 2. So what does that give me? That gives me 2ac is equals to a plus c into b, which looks correct, you know. I mean, that gives me 2 by b is equals to a plus c upon ac, that's just going to be 1 upon a plus 1 by c, which is obviously correct because a, b, c are in a harmonic progression, which means that this option is also correct. Okay, cool, just delete this. Okay, so the next option is a minus b by 2, and then b by 2 comma c minus b by 2 are in a GP. Well, so a minus b by 2, b by 2 comma c minus b by 2 are in GP. Okay, okay, that would be true only if the square of the middle term would be equal to product of the first and last term. So what we have to prove is that b squared upon 4 is equals to the product of the first and last term. Here that's going to be ac minus b by 2 into a plus c. Okay, plus b squared by 4. Okay, this cancels completely, and then you pretty much have what you have b upon 2 equals to ac upon a plus c. Okay, in other words, you have 2 by b equals to 1 by a plus 1 by c. That's nice. So this option is correct as well, right? These are in GP, no problem. I was not expecting that though. I mean, how can so many of options be correct at once? Okay, let's go to the next question, which is a upon b plus c, b upon c plus a are in harmonic progression. It's more like proving that they're reciprocals in arithmetic progression. So b plus c upon a and all that other stuff is supposed to be in arithmetic progression. If we add 1 to each term, that will give me a plus b plus c on the numerator, and 1 upon a, 1 upon b, and 1 upon c in the other part. We can divide this by, and then all the other stuff, we can divide this by a plus b plus c, and that will give me 1 by a, 1 by b, and 1 by c should be in an AP, which is obviously true. So this is correct as well. Wow, all 4 options are correct. That was nice. Okay, so the next question is if a plus okay, if abc are in AP and a squared b squared c squared are in HP, and they are all distinct, then a to b c are in GP, a b c are in HP. I think I did this in class. Yeah, so these are in HP. Okay, well, that will give me 2 by b squared is equals to 1 by a squared plus 1 by c squares, like fine, and these are in AP. Okay, so that will be like a squared plus c squared upon a squared c squared. Okay, but here's the deal, I can write a squared plus c squared as, okay, instead of doing that, let's just write b as a plus c upon 2. So that will give me 8 upon a plus c whole squared is equals to a squared plus c squared upon a squared c squared, whatever. Okay, so that gives me 8 a squared c squared. Okay, I can either do that, or okay, that might be a nice thing to do though. Yeah, yeah, that can be better. Okay, still, let's just do it and see what we get. Not sure where we're going with this. Fine, so okay, so that will be equal to a squared plus c squared into square of these things, like a squared plus c squared into a squared plus c squared plus 2ac. Oh yes, that was correct from the very start itself. Why even do all that stuff? Okay, so this can be written as 8ac upon a squared plus 2ac plus c squared is equals to a squared plus c squared upon ac. That is more like 8 upon a squared plus c squared upon ac plus 2 is equals to a squared plus c squared upon ac. So now you can see where I'm going with that. I'm gonna call a squared plus c squared upon ac as x. So that will be 8 upon x plus 2 equals to x. That gives me 8 equals to x squared plus 2x. Okay, fine. So that will give me x squared minus 2x minus 8 equals to 0. Okay, plus 2x minus 8 equals to 0. So x plus 4 into x minus 2 equals to 0. So x is either minus 4 or x is 2. Well, x can't be 2 because if this thing is 2, right, a squared plus c squared upon ac is 2, then that would mean that a and c should be the same thing, because you would get the equation a minus c whole squared equals to 0. That is not correct, so that discarded. Fine. So the only possibility is that a squared plus c squared upon ac is equals to minus 4. Okay. So what do we do with that? uh, mm, Now we need to find b in this equation somehow. Okay, so a, b, c are in a ap. Oh, here's the thing. Okay, obviously we can do this thing. So we can basically add 2 on 2 on both sides. That will give me a plus c whole squared on the numerator on this side. Right, on this side I will get a plus c whole squared on the numerator, so that will be 2b whole squared upon ac. And when you add 2 to this, that will basically be minus 2. Okay, cool. So that pretty much says everything to me now. We have a relation between a, b and c now. Fine, so that's telling me 4b square is equals to minus of 2ac, which is the same as saying b squared equals to a into minus c by 2. And guess what condition this is? C, right? Yes, the square of the middle term equals the product of the first and last term. That's exactly what we proved right now. That should be it. Okay, this was nice. Let's go to the next question. Let's delete this. I think, yeah, that was it. No other problem. Which of the following is or are wrong? So 1 square root 3 and 12 cannot be terms of an AP. Okay, well, I don't think they can be terms of an AP, because yes, they can't be. Well, if you got 1 and 12 as consecutive terms, then it's obvious that root 3 cannot be a term of that AP, because the difference will be something which is rational and root 3 is not rational. So the only thing is that root 3 should be the middle term, right? In other words, 1 and 12, well, okay, so root 3, okay, 1 and 12 cannot be consecutive terms. But okay, here's the deal. So if 1 and 12 are, say, some terms of an AP, say ax is equals to 12 and ay equals to 1, where x and y are positive integers, that would mean that x minus y times the difference, that would be equal to 11, which means that d would be equal to 11 by x minus y, which pretty much says that d is rational. So every term is basically going to be rational, because you have this condition and this condition. One of the terms is rational and the difference is rational. So if you want to generate the whole progression, that's going to be rational. So root 3 cannot completely be, okay, so completely root 3 cannot be a term of that AP. So this is not wrong, so that can be our answer. Okay, 1, 3, 12 cannot be terms of an AP. Well, I doubt that. 1, 3, 12 cannot be terms of an AP. I think they can be. Yes, they might be terms of an AP. Who knows? For example, if I say that I take the common difference to be half, okay, say I take the common difference to be half, then 3 would be, okay, so 3 minus 1 upon half, that would be equal to 2. So you have to make 2 jumps from 1 to reach 3. So that's nice. 3 is obviously one of them, and then 12 minus 1 upon, wait, not 2 jumps, okay, sorry. So 3 minus 1 upon half, that is 2. So you got to have, okay, so you need to take 4 jumps from 1 to reach 3. Okay, and similarly 12 minus 1 upon half, that would be 22. So you need to take 22 jumps from 1 to reach 12. Is it? Yes, that should be correct. Yeah, I think so. And why not? This can obviously, yeah, these can obviously be terms of an AP. So this thing is wrong. I mean, this is the correct option though, because we have to find which of them is wrong. Okay, and is or are wrong. So this is a multiple choice question. Okay, 87, 25, and 243 can be terms of a GP. Hmm. Uh, well, I guess they definitely can be. They are all positive, right? Yeah, I think they can be. They can be the terms of a GP. Right, so suppose 25 and 243 are two terms of a GP, then sure, 875 can in fact be a term of the GP. Suppose like you take the difference to be 1. No, not 1 exactly. Uh, okay, so what do we know about these numbers? Well, 25 is obviously 5 squared. 243, that is 81 times 3, which is 9 squared times 3 is like 3 power 5. And then 875, that is 5 squares, like into well, what is this, like you got 3 over there, and then you got 412 is like 32, so 32 plus 3 is 36. So that is going to be 5 squared into 2 squared into 3 squared. No problem. So we got 5 squared into 2 squared into 3 squared. I think these can be terms of a GP. Yeah, I'm pretty sure that thing. So what can we do with that? So suppose this is like x, right? So you have to multiply by r x times to get this thing. That will mean that r to the x equals to 3 power 5 upon 5 squared. And then similarly you have to multiply y times to get to this thing, so that will mean that r power y is equals to 5 squared into 2 squared, and then you got upon 3 to the third power. Okay, cool. So can these two be equal for some integers x? That's what we basically want to find. Right, so let's raise this to the yth power, so that will give me like r to the xy is equals to this thing to the y power, and then let's raise this to the x power, that will give me this thing. So that will be, yeah, this is obviously correct. This can happen for some integer. Wait, what? Can this happen for some integer? I do not definitely know that. So x should be something which is like, okay, so these are supposed to be integers. Not sure though. Maybe these cannot be the terms of a GP. Yeah. Right, so x and y should be integers in that case. So what do you get from that? You get like 3 to the 5y into 3 to the 3x has to be equal to 5 to the 2y into 5 to the 2x into 2 to the 2x. That does not look correct. I mean, yes, this is not correct. This is a multiple of 3 and this is not a multiple of 3. So yeah, these cannot be the terms of a GP. Wow, that's weird. I was not expecting that though. uh, yeah, how come those are not multiples of a GP? That is so weird, but that is it. That's how it works. Let's just delete this now. So no, these are not terms of a GP. So that is right, that this option is one of our answer. That is super awesome. I wasn't expected that to happen. Okay, this question is like 6, 162 and then 2 by 81 cannot be the terms of a GP. Let's see. So 6, 162 and 2 upon 81, huh? The least of them is obviously 2 upon 81, so let's increase increasing order. Let's go with the same logic that r, let's just say you have to make x jumps over here and y jumps over there, so r to the x, that's supposed to be equal to 6 upon 2 upon 81. Okay, so that's going to be, well, this becomes 3, so 3 to the 5th power. Okay, that's nice. And then r to the y is going to be 162 upon 6, so 12 and 42, that's going to be 2 and 7, I guess, which is 3 to the 3rd power. Okay, so let's increase into the okay, that is nice, I guess. So yeah, this can actually work somehow. Let's say that we take the ratio to be 3, right? So suppose the ratio is 3. In that case, it is pretty obvious that when you take 5 steps, you basically reach this thing. So multiply this thing by 3 5 times and you get this thing. So x can be 5 and then y can be 3, and yes, these can in fact be terms of a GP. So which means that this option is also correct. But yes, this option, I mean this statement is wrong, which means that this option is correct. Okay, let's go to the next question. Okay, it's obviously visible. So 1 upon b minus a plus 1 upon b minus c equals to 1 upon a plus 1 upon c 10. I guess we have done a similar kind of question already, but whatever, let's just do it once again. So that's going to give me something like, oops, what's happening? Okay, b squared minus of a plus c into b plus ac upon wait, what's this thing? So on the top you will get 2b minus of a plus c upon this thing, b squared minus a plus c into b plus ac, that should be equal to 1 upon a plus 1 upon c, which is nothing but a plus c upon ac. Okay, wow. So 2b into ac minus ac into a plus c, that has to be equal to a plus c into b squared minus a plus c squared to b. Okay, and then plus a plus c into ac. Okay, that's weird. uh, what conclusion? Oh, this is supposed to be a plus c though. That I was not expecting. Okay, what can we do with that? Can we kind of factorize it or something? uh there has to be some way of doing it. Okay, well, obviously this goes down there and this becomes 2 times of a plus c into ac. No problem with that. You got b square and then you got this thing. Okay, oh wow, that I was not expecting this thing to happen. Fine, let's arrange it like a quadratic in b, maybe that will help, right? We might be able to use some discriminant thing, or something which will make it easier. Okay, so this can be arranged as b squared into a plus c. Okay, fine. And then over here you have b into, actually minus b into a plus c minus 2ac, and then this is the constant over there, so plus 2ac into a plus c, that has to be equal to 0. So if we are to find real roots of b, then discriminant should be greater than or equal to 0. hopefully we can find something from that. I don't know if this will work or it won't. Oh, that is a plus c squared. Oh, so that's supposed to be something like that. A plus c squared. Then you got minus 2ac over there. So it's like b squared into a plus c minus b into a squared plus c squared plus 2ac into a plus c, that has to be equal to 0. This is weird. Yes, this is completely weird. Can we somehow factorize this though? Oh yes, yes, we can factorize this, obviously. I mean, yes, this is factorizable. Come on. uh yeah, no need for doing all this stuff. We can basically factorize it easily. Oops, what happened? Okay, so this can be factorized. So we are going to take b into a plus c common from the first two terms. That's going to leave me with a plus c over there. Okay, no, not a plus c, b over there, and then minus a plus c. Okay, cool. And then you have plus 2. Okay, plus 2. I'm gonna take ac common, so that will give me b. Am I going correct on that? Maybe not. Maybe I'm not going correct. Is this supposed to be... Oh wait, sorry, I think I messed it up once again. Shit. Just going to redo that a little bit, because I think I got the wrong equation. So this is more like 2b minus a plus c upon b squared minus a plus c into b plus ac equals to a plus c upon ac. So that's like 2 ac into b minus ac into a plus c is equals to a plus c into b squared minus a plus c squared into b plus a plus, okay, c into a plus c. So that is going to be b squared into a plus c minus b into... Here's the thing, it should have been a plus c squared plus 2ac, right? That is where I messed up. Okay, because you got that minus common already, so minus out, so it should be plus over there, and then plus 2ac into a plus c. Now that is factorizable, no problem. Yes, this is completely factorizable. Okay, so this can be factorized like b into a plus c into b minus a plus c, and then the remaining thing is minus 2ac into b minus of a plus c. So either b is equals to a plus c, or you have 2ac is equals to b into a plus c, which means that... what does that mean? That means that 2 upon b is equals to 1 upon a plus 1 upon c. Yeah, something like that. So either b has to be equal to a plus c, or a... well, wait a second, b has to be equal to a plus c. And that's obvious. That is pretty obvious. Yes, because if it is a plus c, then this is automatically 1 by a plus 1 by c, or one or abc have to be in harmonic progression. So abc are in hp, or b equals to a plus c, so a and c both are correct in this case. It was nice. Just delete that now. Okay, cool. So to the next question, which is that if a2 a3 upon a1 a4 is equals to a2 plus a3 upon a1 plus a4, okay, then okay, wow, that's a big equation. So what can we do with that? We can try adding them. No, that won't be nice. a2 minus a3, that's equal to 3 times of that, huh? There has to be something which we can do. What about theorem on equal ratios? Oh yes, we can apply theorem on equal ratios on this thing. Yes, that should work. Yes. Um, yeah, let's give it a shot. So a2 plus a3 upon a1 plus a4, that is 3 times of a2 minus 3 times of a3 upon a1 minus a4. So if we apply theorem on equal ratios on this thing, let's add them. So that will give me 4a2 minus 2a3 upon 2a1, and this thing is 0, so that's gone. That's going to be equal to um, 2a2 minus a3 upon a1. Okay, what do we do with that now? Oh my god, that's just getting more and more complicated. So you got a1 a2 over there, and you also got a1 a3, but that's negative right now. That is not good. That can be 2a1 plus a4. Then it can be 3 times of a2. Okay, what do we do with that? Oh come on, there has to be something which I can do. Yeah, maybe I can do that thing, like k, yeah, z is equal to k, and then oh shit, this is very weird. Okay, what about I try dividing it? Yeah, let's try dividing it though. Okay, let's see what we get if we divide it. So if we okay, let's think. So 1 will be equal to a2 plus a3, like this thing, upon this thing, that will be 1 upon a2 plus 1 upon a3, and then similarly over here you will get 1 upon a1 plus 1 upon a4. Therefore 1 upon a1 plus 1 upon a4, that is equal to 1 upon a2 plus 1 upon a3. More like these are going to be in harmonic progression. Okay, and what else do we get? Oh well, we sure can do the same thing with this equation. So that will give me, let's see, 1 will be equal to 3 times of 1 upon a1 minus 1 upon a2 upon 1 upon a4. Oh sorry, this is supposed to be 1 upon a3. Why did I write it like that? So 1 upon a3 minus 1 upon a2 upon 1 upon a4 minus 1 upon a1. Okay, that seems, yeah, it seems more like these are in harmonic progression. So that gives me 1 upon a4 minus 1 upon a1 equals to 3 times of 1 upon a3 minus 1 upon a2. Okay, that's one of the nice equations which we get. Then we got this equation. So what can we say from these two? So oops. So yeah, it's almost like these are in harmonic progression. Fine. Yes. Well, in that case you can also prove 1 upon e1, 1 upon e2 and 1 upon e3 must be in arithmetic progression. So let's do that. Let's actually plug in the value of 1 upon a4 as, okay, so you got 1 upon a1 plus, well, 1 upon a4, that is going to be equal to 1 upon a1 plus 3 times of this stuff, that's like 3 upon a3 minus 3 upon a2. That should be equal to 1 upon a2 plus 1 upon a3. That means 2 upon a1, okay, plus 2 upon a3 is equals to 4 upon a2. So that is, yeah, that exactly means like you can just reduce this by 2. So you will get this equality, which means that 1 upon a1, 1 upon a2 and 1 upon a3 are in an arithmetic progression. And yeah, now you can also do the same thing by eliminating 1 upon a1 from it. So that will give me the other equation that says that 1 upon a2, 1 upon a3 and 1 upon a4 are also in an arithmetic progression. So that means that a1, a2, a3, a4 are in a harmonic progression, and 1 upon a1, 1 upon a2, 1 upon a3 and 1 upon a4 are in arithmetic progression. That should be it. That was nice. This was like nice. Let's go to the next question. Okay, so let a and b be positive integers. The value of x, y, z is 55 or 343 upon 55 according a, x, y, z and b are in ap or hp. Then I think we have done this in class. Okay, let's just do this once again. So a and b are positive integers. The value of x, y, z is 55 or 343 upon 55 according to a, x, y, z and b are in ap or hp. So suppose these are in ap, then you get x, y, z as 55. Okay, that's nice. Fine. So a, x, y, z and b are in ap. That means that the difference that's going to be b minus a upon, well, we got 4. Okay, so we can generate the whole progression. So it's going to be a, then it's going to be a plus this thing, so that is, well, guess what, that's 3a plus b upon 4. Then you need to add b minus a to the numerator, so that will give me 2a plus 2b upon 4, and then a plus 3b upon 4, and then b. Okay, these are the values of x, y and z. So that means that 55 is equals to the product of these. So that's going to be 3a plus b into 2a plus 2b into a plus 3b upon 4 cubed, like 64. Fine, no problem with that. Yes, so that should be nice. Now if these are in a harmonic progression, okay, then the same thing is going to happen. Just the thing would be that 1 upon x into 1 upon y into 1 upon z. Oh shit, what happened? Okay, into 1 upon z. This thing would be like the equivalent of the product which we calculated over here, right? That would not be 55. It would be like 55 upon 343, but this would be equal to 3 times of 1 upon a plus b into, so 1 upon a into b into 2 times of 1 upon a plus 2 times of 1 upon b into 1 upon a plus 3 upon b upon 64, something like that. Okay, that's nice. Because basically sorry because basically 1 upon a, 1 upon b and 1 upon c, 1 upon a, 1 upon x, 1 upon y, 1 upon z and 1 upon b, this would be an ap, right? So you pretty much get the same thing, just replace x with 1 upon x, y with 1 upon y, z with 1 upon z, and a and b with 1 upon a and 1 upon b basically. So this is supposed to be 1 upon b, so we get this thing, which is pretty much the same as this thing, just with the denominator being 64 ab cubed, and the numerator is basically the same thing, right? These three brackets same as these one. Okay, and then 1 upon x, 1 upon y, 1 upon z, that's going to be the reciprocal of this thing, so that will be 55 upon 343, right? Because we are given that x, y, z is equal to 343 upon 55 if these are in hp, so it will be the reciprocal of that. That's nice. So what can we do with that? We can basically divide it, right? We are going to divide this. So if we divide this equation by this equation, we basically get 343 on the left hand side. That will be equal to ab cubed, which means that a times b, that would be equal to 7. Okay, so okay, then, well, you got a plus b equals to 8. b upon a equals to 7. That's obviously not correct. um oh, and also a and b are positive integers. That's like a big hint. So a and b are positive, like that's a really big piece of information. So a and b are positive integers. So because we can write it like that, which means that a and b must be among the factors of 7. So either a can be 1 and b can be 7, so a equals to 1, b equals to 7. Or the other thing is that b can be 1 and a equals to 7. What do we get from that? Oh yes, c, a plus b equals to 8. Anything else which we can get? Oh, we can get a as well, a square plus b square equals to 50. uh, b is something which can happen only if a and b are in increasing order. Okay, like if a is less than b, something like that. But that's not given to us. Okay, so it can be any order as long as these are positive, right? So that means that a and c are the only correct options. So that's correct and that's correct. This is not correct, like not correct all the time. This is only correct if b equals to 7 and a equals to 1. This this is not correct. Okay, so that should be nice. Fine, let's go to the next question, which is okay. So this is a passage based question. So till ninth we have this passage. So if a b c d is a sequence of 4 positive numbers such that first 3 are in harmonic progression and last 3 are in arithmetic progression, if the first term is 3 and the common difference of the ap is 2. Oh wait, what? Okay, of the ep is 2. uh oh, okay, fine. So it's a sequence of 4 positive numbers such that the first 3 are in harmonic progression. So a b c are in harmonic progression. Well, a is 2, so you don't have to worry about that. And the last 3 are in arithmetic progression. So b c and d are in arithmetic progression. This is hp, this is ap. Okay, then the value of c plus d is 3 amps inserted between. Okay, so let's see what important information we can get from that. That will give me 2 upon b is equals to 1 upon c plus 1 upon 2. Okay, which is more like, okay, so let's multiply it by 4bc, no, 2bc. So this will be 4bc is equals to, you got 2 over there, that c gets cancelled, so 2b plus that 2 gets cancelled, you got bc over there. Oh, this is not supposed to be like that, so it's supposed to be c only. So that gives me like bc plus 2b equals to 4c. I don't know what this equation is. I mean, what's the importance of this equation? That's what we got, so let's just write it down. So that's the first equation that we got, that bc plus 2b is equals to 4c. So what other equation can we get from that? Okay, yeah, so bcd are in a ap, that means that 2c has to be equal to b plus d. Okay, 2c equals to b plus d. Hey, guess what? We can find a direct relation between no, not yet. We can indeed eliminate c by dividing this, but that won't be a fun thing to do. Okay, what are we supposed to find? We are supposed to find the value of c plus d, which means that it will be better if we divide, okay, if we cancel away the b from that. Okay, that is weird. Oh, and also the common difference of the ap is 2, so which means that, oh, that's nice. The common difference is 2. That's like a big information. So c equals to b plus 2. That is easy as that. So just substitute that into this thing. So that will give me b times b plus 2 plus 2 times of b is equals to 4c. That is 4 times of this thing. It's like 4b plus 8. Okay, so that's going to be b squared plus 2b plus 2b is equals to 4b plus 8. Okay, that's weird. So the common difference is 2. We also know this equation. That's nice. So this cancels. So we got b squared equals to 8. So like b is plus or minus. Oh, these are 4 positive numbers. Fine. That means that b is plus or minus square root of 8. Oh, sorry. Only the positive one. So b is plus square root of 8. Fine. First 3 are in harmonic progression. Yeah, we did that. So let's see what we get. So b is this thing, root 8. So what do you get? You get that b, root 8 and c are in harmonic progression. More like 1 upon 2, 1 upon 2 root 2 and 1 upon c are in arithmetic progression. Let's rationalize this first. So let's multiply this thing by root 2 and this thing by 2 and just leave it like that. So 1 by 2, um, root 2 by 4 and 1 by c are in an AP. So wow, this is very weird. um I don't know why did I get root 8 over there. That's weird. Maybe I didn't do it correctly, because right now I'm getting c as something which is not even rational at this point. So I don't know what happened. Most likely I did the equations incorrectly. Let's do it once again. So c equals to b plus 2, because the last three are in AP. Okay. A equals to 3. I took it as 2 most likely. Okay, fine. So you got 2 upon b equals to 1 upon c plus 1 upon 3 in this case, which means like 2 upon b is equals to 1 upon b plus 2 plus 1 upon 3. That's going to be quadratic, I guess. That is 3 plus b plus 2 is like 5 plus b upon 3 into b plus 2. Okay, so that will give me 6 into b plus 2 is equals to 5b plus b squared. That gives me b squared minus b, and then minus 12, yes, minus 12 equals to 0. So that gives me b minus 4 into b plus 3 has to be equal to 0. So either b is 4 or it is minus 3, but it can't be minus 3 because b is a positive number. So b has to be 4. That was easy as that. Okay, b has to be 4 in that case. So you got 3, 4 and c and d. Okay, that's nice. And also c is equals to b plus 2, that would be 6 in this case, and similarly d would be 8, right? That's a b c d. Okay, are these in harmonic progression? 1 by 3, 1 by 4 and 1 by 6? Let's see. So this is nothing but 4 by 12, this is 3 by 12, and this is 2 by 12. These are in harmonic progression. Very nice. Let's delete that. Okay, cool. So now what do we have to find? We have to find the value of c plus d. That's easy. That's just 14. Okay, if 3 AMs are inserted between b and c, so if 3 AMs are inserted between 4 and 6, and c plus d is equals to k, well, we already know that c plus d is 14, so k equals to 14. Then the value of the third AM is, shouldn't be too hard to find. So 3 AMs between 4 and 6. Okay, fine. So 4 A1 A2 A3, and then you have 6. This is a arithmetic progression, which means that 6 minus 4 is equals to, well, what you got, 1 2 3 4 times the difference. So like difference has to be equal to half in that case. So the value of the third AM, right? The value of the third AM will be, so the third AM will be, you got 1 2 3 3 of half, so like 3 by 2 plus 4, that is going to be, that's what is like 8. So 11 upon 2, which is 14 minus I guess what, 14 minus 3. What is this? 14 minus 3 upon 2, so that's going to be k minus 3 upon 2, something like that. Okay, so you also have something upon 4, so that's going to be 22 upon 4. 22 upon 4 is k plus 8, right? So k plus 8 upon 4. That was nice. Okay, so the next thing which we have to do is, if 6 GMs are inserted between kb squared and kd squared, where k is given in the above question, then the common ratio of the GP thus formed is, okay, 6 GMs are inserted between kb squared, it's like 14 into 4 squared, so 14 into 4 squared, and then you got 6 GMs, okay, geometry, fine, and then kd squared, wait, what? Oh, p to the 7th power. So 4 to the 7th power, 14 into 4 to the 7th power, and then you got 14 into, well, d is 8, 8 to the 7th power, and then you got 6 GMs between this, which means that the common ratio that has to be 14 into 8 to the 7th power upon 14 into 4 to the 7th power. Okay, so that common ratio raised to the 8th power, I think, no, 6 GMs, so that should be like raised to the 7th power. Yeah, you have to make 7 jumps to get to 14 into 8 more 7. That should be correct. Fine. So that gives me ratio to the 7th power is like 4 to the 7th power, so the ratio must be 4. That's the only way this can be. Then the common ratio of the GP thus formed is, well, 4. That is not wait, what? This is, sorry, this is not 4. Why am I doing this? This is supposed to be 2. Yeah, so the ratio is 2, or it can be 1 by 2, but no, that can't be, because we are given this in an order, so that has to be like that. The next question, okay, there's no space. Okay, fine, so let ABC be in harmonic progression, then it's a matrix match, fine. This thing are in, okay, we'll look at the reciprocal first, and then you can add 3 to each term. That's going to be in 1 upon a, oh, that is, this thing is a HP, so is HP, okay, and then B plus C upon a R in, well, I guess this is a AP, so this is AP, and then A minus, oh, that we already did once. We know this is supposed to be a GP. This is just one of the questions which we solved. Then 1 minus, this we do not know yet. Okay, so, but by common logic we know that because only one of them is left, this is supposed to be that thing, right? It's supposed to be an arithmetic geometric progression. Whatever, just move on. It was easy. That it has to be a big question. Okay, in an AP, the series containing 99 terms. Okay, sum of all odd number terms is 200. Okay, this thing 2550. The sum of all the 99 terms of the AP is, shouldn't be too hard. Okay, so there are 99 terms in this, sum of all the odd numbered terms. Let's, you got A1, you got A2, A3, all the way till 99, like A99, fine. So there are going to be more odd terms than even terms, because it ends at a odd term. Okay, cool. So if this was supposed to be 98, then it would be 49 over there, but now it has one more, so there are 50 terms. So there are 50 terms in this, fine, and the difference is 2d over there, so 50 by 2 into, well, A1 plus, yeah, why do we even hit the difference right now? So A1 plus A99, that has to be equal to, guess what, 2550. So when we are supposed to find the sum of all the 99 terms, that's going to be 99 by 2 into a1 plus a99. What is that supposed to be? Well, that's just going to be 99 by 50 of this guy. So 99 by 50 of 2550. Well, guess what that is? uh, 50 of this has, like, this is 2, this is 25 ones are like 2502. That's going to be 51. So 99 into 51, what does that turn out to be? So 99 into 51 is like 5100 minus 51, which is like got a 9 over there, and then, oh god, right, it's 5050 minus 1 is like 50495. So that should be the answer. So 5049. So this is Q. For A you got Q as the answer. Okay, f is a function for which f of, okay, 1 is 1, and f of n is defined recursively by n plus f of n minus 1. Wow. So not a big deal, really not a big deal at all. So like f of 1 has to be equal to 1, f of 2, that has to be 2 plus f of 1, which is 3. Okay, and then f of wait a second, f of n plus 1, that looks weird. We have to find, oh, this is nice, that brings some kind of recursion in there. So yeah, so f of 1 is equals to 1. You got f of 2 minus f of 1 is equals to 2. You got f of 3 minus f of 2 equals to 3, all the way till f of, you want to find f of 100. So 100 minus f of 99, that has to be equal to 100. And when you add all this up, well, this cancels, all that stuff cancels, right? Yeah, this cancels. So just get f of 100 as 1 plus 2 plus 3 all the way till 100. That's just going to be, what is that thing, 100 by 2, 50 into 1 plus 100 and 1 is like 101, it's like 5050. That was easy. So this is R. Fine. The next is, suppose f of n is what? It is log base 2 of 3 into log base 3 of 4 into log base 4 of 5. Wow. Okay, then summation from, I guess it's not that bad. I just have to use some rules for logarithms. So f of n can be written as natural log of 3 upon natural log of 2 into natural log of 4 upon natural log of 3, all the way till natural log of n upon natural log of n minus 1. Guess what? Some stuff cancels out, and then this cancels out as well. So it's going to be natural log of 2, natural log of n upon natural log of 2. That is nothing but log base 2 of n. That was easy. Okay, so summation, okay, fine, of 2 power k. So f of 2 power k, that's just going to be k itself, no problem. So when you're summing up k from 2 to infinity, that is like, how many terms are there? So from 1 to 1 to 100, sorry. So 1 to 100 there are 100 terms, 2 to 100 there are going to be 99 terms. 99 by 2 into the sum of the first and last term, which is 102 in this case. So what is that thing? That's going to be 51. Hey, that's exactly what we got. 99 to 51. That's weird. Okay, we know it's going to be 5049. So right, this is also Q. That's weird. I was not expecting that. Okay, fine. So yeah, that is That's weird. But that's it. That's how we do it. Okay, fine. Uh, and then you got QR. What's with this thing? It just got repeated once. Okay. Let's erase this. I don't know why it got repeated. Delete. Delete this as well. Uh, yeah, it should not have been repeated. Did I do something wrong with this or with this question? So the C is containing 99 terms. The sum of all the odd number terms is 2550. How many odd number terms are there? There are 99 terms, right? So obviously there are 50 of them. So 50 by 2 into a1 plus a99, that is to be 2550. Fine. So upon 50, 99 upon 50 of 2550. That shouldn't be too hard. I mean, this is like 50. It's just one, and then this is like 500 into 5. So this is like 10 into 5, which is 501. Okay, I guess I messed up on this once, right? I don't want that. So 99 by 50 of 2550, that is going to be equal to 99 by 2 of 102. Yeah, it should be like that. 50. So yeah, you got a 5 over there. Oh, yeah, obviously it has to be 102. Like that is 99 into 51. This is how it must be. But then why is that working like that? I mean, I don't know. I don't know why it's working like that. So 2 power k. Okay. And k equals to 2. So it starts with for 4. So it starts with 2. So like all the way from 2 to infinity. From 2 to 100. That, yeah, that has to be one less than that. Like 5049, no problem. And this also turns out to be 5049, right? I don't know what's going on. Let's delete this thing. Fine. So I don't know why it is not working, but fine. Okay, concentric circles of radii 1, 2, 3, 100 centimeters. Okay, is drawn. The interior of the smallest circle is colored red, and the annular regions are colored alternately green and red. So that no two adjacent regions are of the same color. Okay, total area of green regions in square centimeter is k pi, then k equals. Okay, the interior of the smallest circle is colored red in the angular regions. Okay, angular regions are colored alternately green and red, so that no two adjacent regions are of the same color. What does that mean? Shit. Why am I doing all this stuff? Concentric circles. So the first circle is of radius 1. So it's got pi into 1 squared of area. 1 squared of area. So this region, right? This region. This is like red. Fine. The area of the smallest circle is red. Then the next region is green. Okay, so this region is green. It has area pi of 2 squared minus pi of 1 squared. Okay, no problem. So pi of 2 squared minus pi of 1 squared. The next region is colored red. So the total area and it keeps on going like that till 100. Okay. Okay, cool. And then this red region, this will have area pi into 3 squared minus pi into 2 squared. Okay, this goes on till 100. Fine. So the okay, so first one was red, the second one was green, the third one was fine. So all the odd numbered ones, uh, the region below them, that's going to be red. So till the 99th circle, the outermost region will be the red one. Then at the 100th circle, uh, that will be a green region. Fine. So we have to find the sum of the green regions. No problem. So the sum of green region, that should be pi into 100 squared minus pi into 99 squared. But now you go down by 2, so plus pi into, go down by 2, so that will give me 98 squared minus pi into 97 squared, and it keeps going like that till you get plus pi of 2 squared minus pi of 1 squared. Okay, no problem. That should be like that. Fine. So I can use the fact that pi of, okay, I can use the fact that pi of whatever, so n squared minus n minus 1 squared, that has to be equal to 1 into 2n minus 1, right? So this sum, that is basically pi into 2 into 100 minus 1 plus pi into 2 into 98 minus 1, and keeps going like that till you get pi into 2 into 2 minus 1, right? Well, how many of terms are there? So from 2 to 100 you got, like, that's 2 into 1 is 2 into 50, so there are 50 terms in this. So it's going to be pi into 2 into, you got 50 terms in this, so 50 upon 2, and then yeah, so 50 upon 2 into the first and last term is 102, so you got 102 over there, and then minus of 50, that's easy. So that's going to be pi into, well, this is only 50 into 102 minus 50, it's like 101 into 50. No problem. Maybe 101 is a multiple of 7, who knows? I mean 7, 31, no, maybe not. So what should that be? Okay, it is supposed to be k pi square centimeters. So this is going to be k into pi, so k has to be equal to 101 into 50, which is 5050. Oh wow, why is it like that? Well, I don't know, but that is how it is. That's how it works. Yes, fine, it's like 51 into 2, so that's fine. That is how it should be. So we got 5050 as the answer over there. This is R. Just got QR. But why is it like that? 102, there has to be some kind of problem associated with it, but maybe I'm not doing it correctly. And k pi equals, well, whatever, it's gonna go to the next question. So match the column 1 and column 2. Okay, so let's go to the next question, which says that, well, we don't need that anymore. So this says that if p squared plus 9q squared plus 25r squared equals to pqr into this thing, and pqr are real, then no problem. I think I've done this in class, yes. So a, that is like p squared plus 3q whole squared is plus 5r whole square is equal to, well, you got pqr into that, so it's like 15qr for the first term, which is going to be 5r into 3q plus, I guess, You can guess where I'm going with this. Yes, plus 5r into p, plus you got 3 over there, so 3q into p, right? That works. That's basically this equation just rewritten in a more usable form. So now let's multiply this by 2. So that will give me something like uh, yes, that will give me something like 2 p squared. Okay, so if you multiply this by 2, you get 2p squared plus 2 into 3q squared, sorry, 3q whole squared, plus 2 into 5r whole squared, minus 2 into 5r into 3q, minus 2 into 5r into p, minus 2 into 3q into p. Okay, no problem. Now here's the trick. I can write it as, well, I'm going to take one p square from that and put it over here, and one 3q whole square from that and put it over there. So that will give me p minus 3q whole squared. Similarly, take one more p. Wait, what? Yeah, so take p and then put it over there, and take q, put it over there. You get this thing, and then take one more p, put it over here. So p squared minus 2 into p into 5r, so you need a 5r from that, so put it over there. So that becomes p minus 5r squared. And similarly, the last one is going to be for this first one that has to be 5r minus 3q squared. Okay, that's nice. So that is basically like, if this has to be equal to 0, then all of these brackets must be 0, because if they're not 0, then the square of them will make them positive, and you are just adding up a bunch of positive things, so that won't be 0 at all. So these have to be 0. So p is equals to 3q is also equal to 5r. I'm going to call that something, say lambda. So that gives me p equals to lambda. So pqr is basically nothing but lambda, and then q is lambda by 3, and r is lambda by 5. Okay, if I take their reciprocals, then I will get 1 by lambda, 3 by lambda, and 5 by lambda, which is an AP. That means that this thing is an harmonic progression, which means that PQR is a harmonic progression. That should be it. So that's nice. Then PQR in a harmonic progression. Okay, so for A you need T. Okay, so suppose log of P plus R in, and then log of R minus P, and log of P minus 2Q plus R are in AP. Oh wow. Then okay, let us see what we can get from that. Okay, these are in an AP. Okay, so whenever log of some terms are in AP, that's more like the insides are in a GP, which means that R minus P squared has to be equal to P plus R into P minus 2Q plus R. Okay, let us see what we get from that. So we get so we get R squared minus 2PR plus P squared is equals to, we got minus 2q into p plus r plus r squared plus 2pr plus r plus p squared. Okay, so this cancels with that. That gives me 2q into p plus r has to be equal to 4 times of pr, which means that q into p plus r has to be equal to 2pr. That means 2 upon q has to be equal to 1 by p plus 1 by r, which means that pqr are in harmonic progression. So for this as well, pqr in a harmonic progression. That's weird. Okay, so pqr in harmonic progression. Fine. Yes, that's how it works, I guess. Just hope none of them are negative though. So, well, we can't do anything more on that. Well, if p plus r is not negative, r minus q is not negative. Okay, r minus p is not negative. Yeah, fine. So once again, these are in harmonic progression. I don't know why this is like that. Let f of x be equal to px squared uh, plus q. Okay, what is this thing? Okay, this is supposed to be t plus qx plus r be a polynomial function of second degree if f of 1 equals to f of minus 1 and f of f prime of p, f prime of q, f prime of r are in ap, then okay, fine. What am I doing? Yeah, just delete that. Fine, so let's use this information first. F prime of p, f prime of q, and f prime of r are in ap, but f prime is going to be, so f prime of x, that is going to be 2px plus q. Okay, nice. Okay, and these are supposed to be an ap, so this is more like 2p squared plus q. When you put q in there, you get 2pq plus q. When you put r in there, you get 2pr plus q. These are in a ap, so these must also be an ap, which means that these must also be an ap, which means that pqr must be an ap. That's nice. So pqr is an ap, that now we know. Easy. And the other information is f of 1 equals to f of minus 1, so p plus q plus r is equals to p minus q plus r. That gives me what? Yeah, so that gives me q equals to 0. Oh, that's nice. So pqr is an ap and q is 0, so one of them is to be negative. Fine. Okay, fine. Then obviously p wait a second, and pqr are in an ap. Okay, fine. We know pqr is supposed to be an ap, but what if p is equals to q equals to r? That would be, oh no, that then it would not be a polynomial of second degree, but we want a polynomial of second degree, which means that p cannot be 0, which means that these are all distinct. Okay, that's nice. So yes, p is not equal to q equals to r. Okay, so like c, for c you can have q and also you can have r. So p is not equal to q is not equal to r, and pqr are in ap, no problem. And yes, p plus r. Okay, that's nice. Let's go to the next question. And also for this question, this b question, you can still apply q to it, because if p is equals to r, then this thing does not make sense, right? Log of 0, we don't know what that is. Let's go to the next question, which is like three positive numbers p, q, r satisfy p plus q plus r equals to 25, so the sum is 25. 2 is less than p, q, and r, and it is less than 18. So p, q, r are between 2 and 18. Three positive numbers. Their sum is 25, and 2 p, q are in ap. Okay, fine. So 2 p, q are in ap, and q and r 18 are in gp. Wow, that's a lot of conditions though. So 2pq are in ap, that means that 2p equals to q plus 2, and qr18 are in gp, which means that r squared is equals to 18q, which means that we can write everything in terms of q itself. Okay, that's nice. And oh, here's the thing, we know that p is less than 18 and greater than 2, so that 2p has to be greater than 4 and less than 36. That means that q plus 2 has to be less than 36 and greater than 4. So like still q is greater than 2, so no problem, this will get satisfied. uh yeah, fine. And r squared, you got 18q. So okay, r squared has to be greater than 14. 18q. uh you know what, this is kind of weird, you know, because guess what, r squared r squared has to be less than 18, right? I mean, r has to be less than 18, so that means like 18 squared is less than, sorry, it is greater than r squared, which is also 18q. And r squared has also to be greater than that thing. Okay, fine. Then 18q is less than, yeah, that is also nice, so fine. Okay, now let's use this equation. P plus r equals 25, right? So that gives me q by 2 plus 1 plus q plus r. Well, r is nothing but root of 18q is, oh wow, this is, let's just write everything in terms of r. That will be much easier, right? Just write everything in terms of r. So you get q equals to r squared by 18. That gives me 2p has to be r squared by 18 plus 2, so that gives me like p equals to r squared by 36 plus 2. So you got this equation, you got this equation, and r is r itself. No problem with that, I'll just substitute that. So you get r squared by 36 plus 2 plus r squared, sorry, so this is plus plus r squared by 18 plus r has to be equal to 25. What does that mean? Now that's a quadratic. Okay, let's multiply this by 36. Yes, that will do. Or maybe you can, yeah, sure, we can do that also. So multiply this by 2 on top and denominator, so like 3r squared upon 36 plus r plus 2 equals 25. So that gives me r squared upon 12 plus r plus 2 equals to 25. So let's multiply this by 12, so that gives me r squared plus 12r plus 24. You know what, it has to be 23 then. So minus 23 into 12, I guess. So minus 23 into 12 has to be equal to 0. Okay, so now we need to factorize it out. Oh god, that's a big workload. Okay, so now we need to factorize this. How can we do that? 23 into 12, that is, let's choose the smallest factor. So that's gonna be 2, so we got 46 into, okay, 23 into like 46, that's gonna be 40. That's not a good thing though. um what do we have to find though? PQR are in, well, 2PQ are in AP, right? You got the value of R. It's going to be okay. We won't be able to use anything unless we find the value of R. Okay, that can be frustrating though. So we are very near to finding the value of R, but something is not working. Oh yes, this is why it was not working. It has to be plus 1 over there. That's the whole problem. This is plus 1, and then this is plus 1. So instead of being 23, this would be 24 instead. So this will be 24 into 12, which by the way is completely correct. I mean, this is factorizable. So that will give me r plus 24. Yeah, into r minus 12 is equals to 0. So r is either minus 24 or 12. Fine. And we are given that these are positive numbers, which means that r can only be 12. It cannot be minus 24. Fine. So now we know r. Just find p and q. So r is 12. That means that p has to be equal to, well, guess what, r squared upon 36 plus 1, which is, well, you got 4 plus 1, right? So 12 is 6 into 2 is like square is 4 will be 36. So this is gonna be 5. P is 5, and then Q is nothing but 2p minus 2. So 10 minus 2 is what's 10 minus 2 is 8. So you got 5, 8, and 12. What are these in? Are these in harmonic progression? Because that can be the only thing which will be in one of the conditions. So 1 by p is like 1 by 5, and got 1 by 8 and 1 by 12. So that is going to be like what? I think it has to be 8. Fine, let's just see what this is. So 1 upon 8 minus 1 by 5 equals to 1 upon 12 minus 1 by 8. Is that true? Let's see what we get. So that will give me like 5 minus 8 is minus 3. So minus 3 upon 8 into 5, 8 into 5 has to be equal to um, what is this, like 8 minus 12 is minus 4. So minus 1 upon 3 into 8. uh, that is not working at all. So no, this does not work. Yeah, these are in not in HP as well. So fine, I don't know why is it going downhill all of a sudden. Yeah, that should be it. So no problem, right? Okay, then so that is it. P is not equal to Q is not equal to R. That is the only thing which we are getting for this D option. So that's it. That was it. Thanks for watching. I hope you enjoyed.